All right. Thanks, everybody. Thank you, Hashi. It's great to be here. And I'm going to be talking about advanced Terraform techniques. So let's get into it. So I'm John McDonough. I'm a cloud architect and cloud DevOps engineer at Fortinet. You can follow me on Twitter at John A. McDonough. And my GitHub um, user is moving a lot. So what are we going to talk about today? So first I'll say hello and then tell you a little bit about myself. We're going to talk about advanced Terraform techniques, a little bit of code reuse. So Lays is a great presenter to follow. That's fantastic. Some data-driven code, how for each is better than count, and implicit dependencies, always better than explicit dependencies. And I have a typo, not my reop, but my repo for this code and the presentation is at movingalot, github.com, and it's HashiTalks-2023. So a little bit about me. I'm John McDonough, a cloud architect and DevOps engineer at Fortinet. I am from New Jersey, and I work for Fortinet. My hobbies are Terraform and fitness, as well as flying kites at the beach, which I hope to do very shortly. I'm married. I have one spouse. I have 3 children, and I have 1 cat who may come and show himself, jump up on the desk here. So code reuse. What I do is I use Git submodules, and I write modules that are shared across several different projects. And so a little bit about a submodule. What is a submodule? It's a regular repository, and it's added to your repository that you're using it in as a reference to the repository that it is in. And not just the repository that it is in, but the commit level that it is at. And I'll show you that in just a moment. Submodule code is in a directory at or below root. One or more submodules can be added to your project, to your repository. And a new hidden file called .getModules is added in the root of your repo to track all the submodules. And if you want to know more about submodules, you can read about that on the Git website, and I've added a link to that. So here's just 2 screenshots, 2 repository screenshots. One is the one on the left is the repository that I include as a submodule, and I do a lot of Terraform in or for Azure for Fortinet. The AD directory contains a lot of Azure AD resource stubs, if that's kind of what I call them. And then the RM is for the Azure RM provider, and there's a lot of stubs in there as well. And so the repo that I've made for this this event is called HashiTalks-2023, and there's several examples. In fact, there's a 4th example that I added after this. But let's take a look at those red boxes. In my HashiTalks 2023 repo, I have a link back to, or a link to the other repo called Azure, movingalot /Azure in github.com. And you can see the number or the SHA that it's referencing is relative to, or it's referencing the commit that I'm using in this repository as a submodule. Now, don't worry if that repo is updated. You can pull that updated repo as a submodule into your project. Just like you would do a get pull into a repo, you can do a get pull of the submodule into your repo and update. And then just push that update of your repo and the up to GitHub so that we are referencing the new commit for that submodule. So what I do with Git submodules in Terraform code is I keep generic resource code in a Git repository. That's my repository called Azure. And then I add that as a submodule to my projects. Each resource module is a distinct object. Each resource output, or the output from that module, is a single object. All attributes are variabilized. So I call that module like it was a function in program code. And then variables.tf defines defaults, descriptions, variable validations, anything that I need to put in there to ensure that when I call this module, I get, expected behavior. So how do you pull that Git repo as a submodule into your repo? In the repo that you've just cloned, you say git add submodule or git submodule add, excuse me. You add the remote repo URL, and you can optionally add a destination folder. You then git commit and put a message in like added submodule, and then push that. And so when a submodule is then updated, you can pull that update, commit it, and then push it up to your repo. And then you commit and push your repo up to Git so that you now have the new SHA or the new reference for that submodule committed to your repository in GitHub. And so this is kind of what it would look like very first stage in something like VS Code. If with the Git or the source code module being utilized, or source code, you would have your Azure repo. That's what I call my repo. And it shows an S there as a submodule. So what do the commands look like? So here's my initial cloning of a repo. I always init my repos on GitHub and then clone them down. So here's my initial clone of the repo that I created up on github.com. And then my next step is I change directory into that repo, and then I do a git submodule add of the repo that I want to be a submodule. Then I commit it and I push it. And then this is what I will see in my code editor. I'm using VS Code. So what's a generic module look like? Now we've gotten the Git part out of the way, or the GitHub part out of the way. What does a generic module look like? So that Azure repo of generic modules, this is my generic module for a public IP. Like I said, everything's variabilized. And the way I create my variables is the attribute name is a pretty good name. So why make up a new name for resource group or a new name for location? I just use the attribute name as a variable name so I can pull that into my repository, and everything is very similar to me when I'm looking at it. When I look at, or if I see an error, well, the name pops out of I know it's a resource group. So this is the generic module on the left-hand side here. On the right-hand side is that variables file that goes along with this generic module. So I've put description in for every one of the variables. And in some places, if I have a default, like the tags, maybe I've defaulted that to none if I didn't want to make somebody put tags in. And so now when I call this module, I know that I have to send the ones that don't have defaults. And I've also specified default for ones that I just want to make optional. So how do I go ahead and use that? Well, so now what I want to do is create a module that calls that generic resource. In this case, I have a module in the top left there that uses a locals variable to loop over to create public IPs. I specify my source as the generic module, and I send along each one of those variables that are coming in from that for each loop that I'm doing. And then it ends up creating for me a single public IP object that it sends back to my module. Now, what I do in my module that I use to call this generic resource, I create a list of all the outputs. So if I was creating one or more public IPs, I would have a list of those public IPs that was just created. Actually, not a list, but a map. And what's the differentiation there is that I can reference my public IPs by the name or the key of my variable that I used to create it from locals. So if you look at that bottom section of code here from my locals, I have a public IP that I'm calling pub IP1. So now if I want to reference that public IP later in my code, I can reference it by its name from the public IP module that it was created from. So it creates a very hierarchically well-organized code that I can always reference. And we're going to see something later in the talk here where I talk about implicit dependencies. And you're seeing it right here for the first time for the resource group name and for the location. Those components or those attributes are referencing the resource group that was created. And this public IP component can only be run after that resource group has been created. So you are enforcing explicit dependencies here, or enforcing dependencies by referencing something that could only be created before this thing could run. So this leads me to something that you've kind of seen here. By using the locals in conjunction with generic resources, I've abstracted from my code any sort of static coding or hard-coded dependencies, and I've put them into my locals. So now I don't necessarily have to change my code. I just have to change my locals when I need a change to the variables or a change to what I'm creating, the infrastructure that I'm making. So again, this is just a re-showing you how those locals provide the values into my module that calls my generic resource. I can look at my module and I can see that I wouldn't have to make much change here if I want to take this and put it into another project and call the shared code from my submodules. But let's take it a little bit further. A lot of times when I'm creating environments for my users or for a training event, we need to create more than one resource group per user in Azure. Now I could, in my locals file, list this all out. I could do this scenario where I take these 3 users that are pictured on the top right and the 2 resource groups that each user will need and write all that data out. Make a resource group for user 1 training, make a group for user 1 utility. I could do all that. Now, if I had 3 users here and 2 resource groups, well, that's 6 resource groups that I would need in the end. Each user would get 2 resource groups. But imagine if I had 20 users and 5 resource groups. Well, that would be 100. And my file would be extremely long. And even with all the cutting and pasting and even automated generation of that data by some other thing, I might make a mistake. So what I'm using in Terraform is some functionality to make these 2 pieces of data into a list by using set product. So set product creates a list of these 2 components together, sort of merged together. And then I use the ability to create an object or a map object by looping over that list and creating objects. And that's what I'm doing in the code on the left-hand side. So the first line in that code creates that list of merged components. And then the second piece of code from user resource groups map down to the bottom creates an object of those things meshed together. So the first line of code creates what you see on the left. It's a list of lists of maps. And then I take that list of maps and I turn it into a mapping of user resource groups. Now I've done some things there. When I create those objects, I use the username and hyphen the resource group name as a component of the resource group. And you can see it created this object for me that I can now iterate over with a for each. And that's key. And you're going to see that in the next component here, or the next part of my talk. Being able to map or iterate over this list of user groups, or resource groups, excuse me, I can reference things by name at any place in my code. And it makes for a great way for me to take multiple things that I might need to merge together. It might be a role that I need to apply to multiple users or multiple roles. So I can generate this data dynamically. That's why I call this data-driven code, because the data is what we run through the resource or through the module that calls the generic resource. And this way, those things remain very I don't want to say static, but they remain very static, and it is the data that is generated that drives the code. All right, the next part, for each. Why is it greater than count? And we know that at one point, count was all we had in Terraform. But now with for each, well, the world has just opened up. Let's talk a little bit about count. Count equal to the number of things you want to make. Count as a conditional, make the thing or don't make the thing. Count set to the length of a thing, a list that you want to iterate over, and it's good. But the objects that get generated have to be referenced by their index. Now, previously, when I showed you maps, I referenced the object by the name, by its key name. It's very easy. I can match a key name. I can know what that object is, where it was created from, what it's for. But with count, I'd reference it by its index. And maybe I don't know where it got created in that list. Maybe that list's not in the order I expected it to be. Maybe count just isn't as good as for each. And so I have a little image there of throwing count in the garbage. I don't mean to be mean to count, because it was good. But for each is way better. My advice, don't use count where you can. So how does count help us? How does for each help us? For each helps us in a way that you may not expect. Now, going back to that conditional creation of resource groups, or that creation of resource groups, now I want to add a conditional. So that code that I generated before, or I used before to generate the list that became my map, well, if I look at that object creation, right at the very bottom, there's an if. If item 1 bastion is equal to true, then I want to create that resource group. But if it's not, I won't create the resource group. So I'm using conditional object creation in my dynamic data to determine if I want to create a resource group or not. And that's one way to do it. So when I look at user resource groups map filtered, I've only created a map of 3 objects. But if you want to, you can put that in the module. And now in the module, if I look at the top of my module, say I didn't have a filtered group. Say I just had that group from before, that unfiltered, all the resource groups that maybe all had bastion set to true. Well, I can create a for each, and I can check a variable. Am I doing bastion host support? And if that's so, then what I want to do is loop over the objects in that unfiltered group. And if the user.bastion value is equal to true, then I want to create those objects. And if nothing was true, say we're not doing anything with bastion hosts, well, I can just have an empty map there. Not a count that says yay or nay, but either some things to work on or nothing to work on. And I like that better because maybe my code doesn't always generate, or if I'm using count, maybe I didn't get all the correct conditionals or things set up, and maybe I get a false positive and I create something when I don't mean to. In this case, I either have things that I want to work on or I don't have things that I want to work on. So in here, I'm doing conditional object generation utilization. I think I have that slide in twice. Okay, so we'll move on to the next one. So another thing about for each that I think is great. Oh, I know what I want to talk about. Another thing that I want to show you is that when I've created these objects, or in my code, I might have dynamic blocks inside that code, and we can use for each for that as well. So let's take a look at my locals for a load balancer. Now this load balancer, or actually 2 load balancers, is going to be using some generic code to generate that load balancer, my generic resource module. And for the external load balancer that I have at the top, named external LB1, I'm going to create two front-end IP configurations. And for the second load balancer called internal underscore LB1, I'm going to create one front-end IP configuration. Now, the top one is creating two public IP front ends, or two front-end IPs that are public IPs. And the bottom one's creating a front-end IP that's a private IP. But I'm using the same exact generic resource, but I'm making a determination at the time of load balancer creation of those front-end IPs, which one I'll be creating. So my module, it's very generic. It calls my generic resource called Azure RM underscore LB, and it outputs back to me a single, it outputs all the load balancers that are created after this module is run, because it runs for each one of those two load balancers that I want to create. This is my generic resource that I call from my module. And so the top section, the top dynamic block, will only run, again, there's that for each and why it's better than count. For each time a front-end IP configuration that I'm sending through from my locals, if there is an attribute called public IP address underscore ID, if that's not null, then I'm creating a public IP as my front-end IP. But in the bottom dynamic block, I'm using the for each to determine if I have a private IP address attribute being passed to me. And if I do, well, then I'm going to create a front-end IP that's from a private IP address. So a single generic resource is now being able to create two different types of load balancers based on the IP configuration that's being passed through. And not just a single front-end IP, but as many as you pass through to it. The last thing I'm going to talk about is implicit dependencies. In this case, I have my locals. And in my locals, I have a virtual network that's being set up. And that virtual network is being defined by a name that's coming out of my variables file. Its address space is being defined by a name that's coming out of, or by an address space that's coming out of my variables file. Now you can see right above the name and address space attributes, the resource group name and the location are dependent upon the resource group already being created, because we're querying, and I know this seems silly because I'm putting it right in the attribute value there, but we're querying the name of the resource group by using the variable name of the resource group. We're looking at the object that was created for the resource group to get its name. That's what makes this dependency implicit. I have to have a resource group before I can go ahead and use that in my virtual networks object that I'm going to be creating. So when you look at the subnets that I want to create, so subnet 0 is using the name variable as the key to the output from the module that created the virtual network. So I'm asking for the name of the virtual network by using the variable that has the name of the virtual network in it. But this enforces an implicit dependency. Similarly, let's look at subnet 1, where I'm using the address space from the virtual network that was created. That object that was created, I need to pull that address space from the object. Instead of just using var.virtual network address space, I'm actually looking at the object that was created for that virtual network. So these implicit dependencies will enforce that plan to run in an order that makes sense. Resource group, public IPs, virtual networks, subnets, on and on and on. And if you reference those things that had to have been created before you create the thing that depends on them, well, then that's implicit dependencies. And you're in for a better deploy or better create and an easier destroy as well. So I have some code that I want to share. The code, just to give you a layout of how I put this all together, I have examples for each one of the components that I talked about. The dependencies, or excuse me, the generic modules. So if I look at my public IP, it's referencing Azure RM public IP. And there's my submodule brought in to my repo. And if I look at my submodule and I look at my RM directory, subdirectory, you'll see that I have generic resources for all those things that I want to create. Now, I update this repository of Azure generic resources every time I encounter a generic resource that, well, I need to add to, or I encounter a resource I haven't created yet. In one of my deployments, I add it to this, I update my generic repo, and then I updated all my projects that are based on that submodule, I pull it in, I run some automated testing and deployment, etc. But that's how I can share my code from project to project to project. Now, I should say, this is the way I do it. I know there are other tools out there that it can be utilized to switch environments, to pull in different configurations, whatever it may be. This is what works for me, and this is the way I plan to keep doing this. Unless I see something better, and then I'll change my whole attitude and I'll change my structure of everything. But no, I think this is a good methodology for me and the way I like to deploy things. So we have the generic resource that gets called, and the public IP one is right here. And you'll see I broke it down in just to the public IP generic resource and the variables that go into that generic resource. Similarly, I have for load balancer, backend address pool, whatever it is that I run into in my deployment, I utilize that. I create a generic resource to make that. So that's what happens in example one, just the utilization of a generic resource and how it lays out. A resource group gets created and public IPs get generated under that resource group. And then the locals provide input to those modules. So it's very simple, straightforward example. The second example goes through that idea of object maps, turning different sets of variables, meshing them together and turning them to a map so you can reference them. That's the second example that I have in there. The third example that I have takes that idea of the locals meshing groups together to create a matrix, and then taking it one step further by using the conditional to create an object or not when objects are being created. Or if you have this list, just like the previous example where it's unfiltered, all the resource groups get created as a map. When I go to create the IP addresses, that's when I can use that for each. That's in example 3. And finally, in example 4 is where I take that for each and I really, really use it to my benefit. When I create my load balancer, I have a generic module that calls my resource, and what it passes on to it is each resources. I got to get to the right place. The public IP, front-end IPs as a list of maps, and it loops over that list of maps, and I can reference each one of these components, but I key in on these attributes. Is public IP address in there? Or is private IP address in there? And depending on which attribute exists, that's how I determine what object I'm going to make, what dynamic block I'm going to run. So this is out there on GitHub under Moving a Lot, so /HashiTalks-2023. Take a look. You can always enter an issue if you find something and ask me any questions you like. Hopefully, this has been worth your time. Thank you for attending. Thank you to HashiCorp and everybody that's out there. I wish you the best with Terraform, and I'm here as a resource if you ever need me. Thanks so much.